Coming up on the Open Align show, Team Scream and Team Scream Junior are both on the showcase their current robots' progress and what they've been working on here in Crescendo. A lot has happened since we had them on just a few short weeks ago. Team Scream Junior will be on the showcase their chassis and kind of just how some of the motion of their robot works. A lot of cool stuff with that. And then Team Scream Junior is going to be coming on to showcase their climbing and trap scoring mechanism. I really like the thought process. You're going to hear about these little prongs that they have coming out on their robot as well too. Really neat with that. And then we're going to be diving a bit more into some of their other areas of their robot, how that note is moving through their robot, these cool kind of guards that they have to center the mechanism as well too, or center the notes as well too. So let's learn more about their current progress coming up here on the Open Alliance show. This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. And joining us now on the Open Alliance show is, we got a twofer once again. It's 4522 Team Scream and 4766 Team Scream Junior. So many cool updates to go through. I know we got a robot chassis on the table there, but lots of updates to have since we last had these two teams on the Open Alliance show. So we can't wait to dive right into it. We got two great students on here. So why don't you introduce yourselves? Let us know what you're doing in the team, and we're going to hop right into some of the updates you've been working on.
All right. Hi, I'm Parker Ellison. I'm the team captain.
Hi, I'm Brooke. I'm an engineering lead for 4766.
So you got a lot of updates. They said we'll be going through kind of on both teams, but give me a general progress update on where both teams are at overall so far as we enter into week 6 of competition, or of the build season, I should say.
Yeah, so we should have both of the robots fully wired and assembled by the end of this weekend. And we are kind of a week behind, but we feel really good about where we're at right now.
Okay. Can you give me a little bit more in regards to just kind of what some of your statuses of things, like where you at just as a broad perspective? And then is there anything that you're like, hey, like we are really far behind in this, or we've had to go a different direction on?
It's just getting some more parts out, I guess, and giving more time to our wiring team and our programmers.
Okay, very cool on that. One of the things I know we do have a video of is that you have built an absolutely gorgeous field, by the way, as well, too. Let's put that up on screen and just talk to me a little bit about this progress of like getting it together. Like this looks competition ready right here.
Yeah, so our machinists worked really hard for that. We're sitting at, our machinists have made 2,000 parts this season so far, and the field was 1,500 of those. So it took a lot of work, but we're really, really fortunate to have been able to make that, and we're really glad that we have that available to us.
No, this is really cool. And it's just like was this an AndyMark field perimeter you already previously had, or did you buy everything this year, or what was some of the progress on that, or how did that go all together?
Yeah, well, this is our new practice facility that we made, or that got built for us this summer, and then we already had the field, and then we just had to make all like the stage components and stuff.
Very, very cool. As we mentioned, we're going to be covering two teams and robots here today as well. So, Brooklyn, talk to me about the current update on 4766. I know we got the chassis in front of you for that team as well. Run me through some of the superstructure and what you've been all working on.
Okay, so during the last week, we've worked really hard to try to get majority of our robot together. We've spent a lot of time trying to get this intake together and the chassis, which is what I worked on the most. We've worked a lot on trying to get the spacing for our climbers together and the pivot for our arm, which will have a shooter on it soon. And we're going to be scoring into the state or into the speaker at a stopped point right here. We have hard stops on our chassis. It's going to be scoring up, and then we're going to tilt over and score down into the amp.
And what's kind of your next steps progress-wise right now for your team? Obviously, you got a lot of that together already, but what are some of the kind of the finite things that you really want to work on over the next week or two as you get ready for competition?
So we really want to work on trying to get all our electronics together, which will be underneath. We have our battery dropped down below as well. And we're just really going to try to get everything working correctly so we can get our drive team and programmers a lot of time to be able to correct everything and make sure it runs properly before our first competition. We're just really going to be focusing on making sure all the geometry is correct and making sure it can score efficiently.
Can you walk me through a little bit how that note journey works in your robot? Like how, I can see that intake on the front there. Walk me through like where the note's coming through and how that handoff works and everything like that.
So we have an under the bumper intake. So our note will be picked up from the ground and it's going to go under the bumpers, and our shooter will allow our arm to be sat at an angle almost like this. So it's going to go up. We might need to make some sort of angled piece so it can run directly into it, but it's going to go up. It's going to have some hard stops with beam brakes, well, soft stops with beam brakes, and then it's going to tilt over and make sure it can score downwards using flywheels at the end. Or it's just going to use those same flywheels to go up into the speaker. And it's just really going to try to be simple and fast.
No, that's really cool. I love the thought process, love the geometry that's gone into that as well. Anything else that you want to talk about from Team Scream Junior's robot and current progress?
I just think that we've really worked hard the last week to try to get everything really fast. We were behind, but that's because we were focusing on our CAD to make sure it was really good, so that when we machined our parts, we wouldn't have to remachine them and waste more time doing that, because we just really want to make sure that the geometry to go down into the amp is correct and that we can still score into the speaker as well.
Well, best of luck on the continued thing of that. We can't wait to keep following along with 4766's robot so far. Let's talk about 4522's robot and some of the updates for that too, and what you've been going through. And we got a couple of videos we're going to show for that, and so some cool stuff will be shown on screen. I can't wait to talk more about this. Walk me through this huge set of components you have here.
All right. My name is also Parker, and this is our shooter box that we have. This side over here is where we're going to, this is the amp side of it, and this is also our shooter side. So our floor intake will shoot into our amp, and this will suck this in, and we'll keep it about right here. So then we're able to, if we want to score in the amp or score in the trap, we're able to by shooting, or not trap, sorry, the speaker. We can shoot through the amp with these flywheels, or we can raise it up and pivot it with our elevator to shoot into the amp.
But you do have a trap scoring solution as well too, right? So talk to me about what you're doing on for that, and we'll put it up on video too.
Yes. So I'll explain it real quick. This part not only... Oh, you got it on video. My bad.
That's fine. Walk us through what it is.
So this is also our amp side of the robot as well. So it has a dual purpose thing to it. And you can see those red little antenna looking things. That is, we tried shooting the note into the trap, and it's got stuck every single time because the polycarbonate sticks to the note and does not let it slide. And so we had to find a solution that would allow the note to slip through. And I'm going to pull this other video to see, so we can see this. So on our climber solution, we are able to climb up completely up to the trap and use our amp side of the robot to also trap as well. And you can see here, we're able to put the amp at an angle to where it's able to go in. And then with those red HDPE antenna things, we're able to open the trap door. That way it allows the note to slide in efficiently.
No, overall, this is really cool. I love seeing the process of how this works. We haven't seen too many teams really showcase what this climb and trap score is going to look like on here as well too. From your end, obviously as you're going through, this is pretty slow right now through testing, right? Are you looking at doing anything to try to get a bit faster, or maybe what is your objective to climb and score and trap at the same time? How quickly do you want to do that once you get to a match?
So right now the climber is set about 10% power or speed on the motors. So in match, we'll be able to climb considerably faster, and it won't be near as big of a deal in match.
Is any of that going to be automated at all, or is that all going to be on driver control?
So I think most of it will be automated to where it will climb up, and then it will get us in the correct position. That way, all we have to do is manually shoot it in there.
Very cool. Well, there's a lot of things to talk about on your robot as well, too. So let's hop into some of the things that you have been working on with that as well. What do you want to talk about next? Because I know there's a lot to cover.
So you want to cover the chassis?
Sure. So there was a lot of thought that went into the chassis here. And a big thing was the fact that we want to be a tank. We want to be overbuilt and we don't want to break down a lot like we did last year. So this chassis is really low to the ground. All the electronics are deep into the belly pan here. And if you can see it, you probably can't. But this belly pan is one big piece of sheet metal that extends down almost a quarter inch off the ground. That way, all the electronics can sit there, and it makes the mounting for the elevator, the climber, and the winch for the climber considerably easier because of the plates that we have on the side can reach down and be really low to the ground.
One of the things that you all talked about, or that I've seen as well too in your blog, is that you're going. You mentioned you want to be a tank, right? Which means you're going to go very heavy for something like that. From your testing side, obviously it's going to keep your CG low. That's going to look great. Have you had to do anything to try to lighten your chassis at all?
So whenever we got all the master CAD done, we weighed in at 134 on the computer, and that is over weight limit. And we went on a rampage of lightening as much as we could. That way we can be under weight limit and be legal. So what we've done is there's a ton of holes in the chassis to lighten it, and we even converted some of the channel to C channel. That way we can be even lighter than what we normally would be. And all the other subsystems have done the same thing. Our chassis dropped about 9 pounds with all this lightening to it. The climber dropped, the elevator dropped about 2 pounds, and the shooter dropped 4.2.
The shooter dropped 4.2 pounds, and that's from also putting lightning holes on the side panel. But also, we changed the standoffs to 3/8 inch thick instead of half an inch, and that saved a ton of weight.
That's a lot of lightning holes, we'll say, and a lot of lost weight.
Yeah,
that's actually quite impressive. You'd be able to take out that much with that as well. So we got some other cool things to talk about with your shooter and your handoff area. So let's jump into those. I know we got a couple of videos to show. Let's start off with your handoff area. I'm not sure if there's anything you want to show on camera, but I know we got a couple cool videos for that as well.
Yeah, we have a couple cool videos, and I'll pull that up real quick. Okay, so this is on our just a little quick setup of our robot, and you can see there how it goes from the floor intake to the amp side and sits in that little spot right there where we can either score an amp or score in the speaker. And we will have that on a elevator, but right now we just put like a little mount on there so we can test the theory about it.
By the way, I'm really interested in hearing about this. I'm not sure if that's a 3D printed area where that yellow is when the ring or the note initially comes in. Can you describe a little bit more what that is? That's kind of centering that note for you.
So yeah, that is a funnel that we have right now. That current one that you see on the screen, we don't know if that's going to work for a final robot because of some of the changes, like with the elevator that we've made. So we're going to try without using it. And if we need to make a new one, we're going to try to change some things for that.
That's really cool. Have you discovered anything else in the process of creating this that are things maybe you do want to change into your final assembly?
So a big thing is our trap was unreliable. We thought it just had a lot of it just wasn't as reliable as we would like it to be. So we made some big geometry changes in tilting the elevator from a straight 90 to a 10-degree angle. So this way we will have a lot easier geometry when it comes to trapping and amping as well. The only downside is that we don't know 100% if the handoff is perfect. That's the only thing, but we will be able to test that, and we might be able to figure that out.
Oh, very cool.
And you can see if you pull up my screen, I have the CAD pulled up, and we can kind of show that angle. So you can see our elevator went from 90 to 80 degrees. So now we're going to hopefully get closer to the edge of our robot, to the bumper, and it'll be more reliable to amp and trap because we can have more of a downwards angle, and that's due to the elevator obviously being tilted.
No, that's really cool. It's great to see this assembly really starting to come together. This looks awesome, guys. By the way, I just love everything that's gone into this so far. And your under the bumper intake, I think, looks great. And that whole handoff process, I can't wait to see all that come together. We haven't talked about your shooter yet. Talk to me about where that progress is right now. I know we got some testing videos to showcase as well too.
Okay, so yeah, the shooter has been, and I'm gonna pull the video up so we can see some of the shooting, some of it actually shooting. So this is one of our earlier prototypes when we were just testing what is the best wheel configuration. And so you can see we slammed all the wheels to the left. And so the reason we did that is because we're trying really hard to get spin onto the note, because when there's spin on the note, it's way more reliable to shoot. Not only straight, but it doesn't dive up or dive down. And we were playing with multiple different configurations. And on our final robot, and I'll go back to the CAD to show that, we decided to go with 3 wheels on each axle. And on those wheels, these two over here are 2x4 Coulson wheels. And the other ones are 4 by 1.5 wheels. And the black wheels are considerably more grippy than the Coulson wheels, which creates that spin. And we did a ton of playing around with how far the wheels are from the sidewalls. And we came to a conclusion that 2 inches from the sidewalls is definitely the best for consistency and speed. And it still allows it to have very, very good spin on it too.
Well, so much to dive into with this robot you've gone through. It's great to see all this progress your team has been making. Anything else that you want to give us an update for? I know we're getting into that grind week, that is week 6 and that sort of thing. So anything else you want to leave us with before we let you go?
So yeah, right now on our final robot, we are very close to getting all the actual subsystems machined, or not machined, but assembled. And so right now we have obviously the chassis and the intake done. We also have the shooter, the final design for the shooter, which we showed earlier. But now we're just kind of waiting on the elevator or the climber and the elevator finish.
Well, Teen Scream and Teen Scream Junior, we can't wait to see how both your teams wind up here. You had such a both teams had a phenomenal year last year, so we know going into the competition season, I know you got high hopes for yourselves, but we can't wait to see as a community how you do as well. So thanks for telling us about it. Good luck during the rest of your build season, and we can't wait to keep following your progress on your Open Alliance blog. Thanks a lot.
Thank you. Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.